And so we'll go back to our clusters again here, click weather demo, and now under tasks, we can actually run a new task. If we were to run a new task, we can select our single task definition that we created, and we could take a look at how that works. Let's go ahead and just create the remaining 3 task definitions though. So we have weather precipitation. Let's go ahead and create weather temperature. The same task role here, and we're also going to run on Linux. Everything's going to be just the same, except we're going to run a different image and have a different set of environment variables. So ECR here, we're going to grab the temperature image. We'll call this weather temperature. We paste the URL and then latest from ECR. We map port 5000. Everything else is okay here except for our environment variables. So again, here we need to specify connection strings underscore appdb with a value of this, except that we're going to change the database. So we paste this, and instead of cloud weather precipitation, we have cloud weather temperature and then semicolon. And then ASP.NET Core 1 underscore URLs, HTTP : / plus 5000. HTTP : / plus 5000. Okay, all else should be good, I believe. So we'll go ahead and add this one, and we'll add, or rather create, this task definition. We'll view the task definition. We can head back to all of them. Now we'll create our weather report service. So weather report, same role, same operating system, same compute and memory allocations. And now we'll go ahead and grab from ECR our report container, tagged latest. Oops, that's this one. We'll call this weather-report, mapping port 5000. Come down here, and the environment variables for our report are a bit different. If you recall from the code, we take a look at cloudweather.report. We have an app-settings.json file that has this weather data config object. So we need to specify the protocol, host, and port for each of our other services here. And so in fact what we need to do is we should determine what the host is by running services for our 2 temperature and precipitation services. So what I'm going to do is in a new tab, we're going to leave this open. We're going to head back into Amazon ECS. We're going to go to our clusters, click our cluster, and we're going to create a new service. So let's create a service here. It's a Fargate launch type, Linux. We're going to start our precipitation service first, revision 1. We're going to call this precip service, 1 task, leave everything else just the same as it is. And we go to the next step, cluster VPC. We need to make sure that we select the appropriate VPC that we created earlier. And then subnets here, we're going to place this in two available private subnets, US East 1B, and let's see here, US East 1A. For security groups, we need to make sure that port 5000 is open. So let's go ahead and edit this security group, and we're going to call this .NET Services for now, maybe .NET Weather Services. And we're going to say allows port 5000 from anywhere. For now, we're going to allow it from anywhere. And so we're going to do custom TCP of port 5000 here, and source from anywhere. So we'll go ahead and save this. This way, our weather report service can connect to our precipitation service. It's listing on port 5000, and so we need to make sure that our firewall, if you will, our security group is open there. We will disable auto-assigning a public IP address. We won't set up a load balancer. We won't set up service discovery, which I mentioned as a topic for later. So we'll go to the next step. Next step, we won't worry about auto-scaling, and we'll just go ahead and create this service. Now we need to sort of keep a close eye on this to make sure that things are going to run properly. So we'll head over to View Service, and what we'll see here in just a moment is that a task of weather precipitation revision 1 is now being provisioned, and we can see that the desired status is running. And so shortly we should see it move through a number of different statuses here. It's now in pending, and if we wait just a few more seconds here, it will be in running. And so we can see that here. What we want to look at now are the logs. We should see .NET logs coming out. Okay, so that's looking good. So if we head back to details here, you can see that things are looking good. We're in a running state, or an active state here on the service. If we head into the Tasks tab and click on the running task, we actually see the private IP address. So this is the private IP address within the space of IP addresses we have in our VPC, in the private subnet, where we can actually connect to our precipitation service here now. So we want to copy this and then head back to where we're setting up environment variables for our report service, and we want to basically know this host because the weather report service needs to know where the precipitation microservice is running. So here, I'm just going to start typing here, and then we're going to paste the value in for the host, and the name of the configuration is actually weather data config __ precip data host. Again, corresponding to our config layout here, weather data config __ precip data host. Protocol and port will also be pretty easy here. Protocol, weather precip data protocol will just be HTTP, and precip data port will be 5000. Now we're going to have the same for the temperature stuff. So we have temperature protocol, temperature host, and temperature port as well. Host and port, or port rather, is simple as 5000. Protocol is simple at HTTP. Now we need to run a temperature microservice to see where it's actually running. You can see this is where service discovery would come in very handy. We don't want to have to update this config every time the temperature service or precipitation service goes down, which we would have to do in this case, and check that what the new private IP address was when the scheduler scheduled it against some new compute in the private VPC. We would like to be able to resolve this via DNS, like an internal DNS, where we say something like host is just precip host, and then that gets resolved to some IP address, and that IP address is managed by some service discovery software. Okay, so let's go ahead and head back to ECS. We'll go into our clusters. You can see we now have one service running. We want to go ahead and create a temp service. So Fargate, task definition is temperature, revision 1, service name is temp service, number of tasks is 1, and rolling updates. Next step, cluster VPC. We need to select the correct VPC, and we're going to place this in some private subnets. So this allows placement of any number of tasks in these private subnets. The security group here, we're going to use an existing security group, and we're going to use our .NET Weather services, which allow inbound from port 5000. We'll go ahead and save this. Disable publicly assigned IPs and or automatically assigned public IPs. And we scroll down, go ahead and go to the next step. No auto scaling, and we're just going to go ahead and create our service. Okay, so once again, this will just take about a minute, maybe a little bit less, to actually get up and running. While that's going, we can click on the task, and we can already see where the task is going to be placed. So we'll just grab this private IP, and we'll paste it into weather data config __ temp data host. So this is where our precipitation microservice is running, and this is the host where our temperature microservice is running. We'll leave all else the same here, except we need to remember to add ASP.NET Core _URLs. Again, HTTP:// +:5000. and then we'll come down here and everything else looks good. We'll go ahead and add this. If we need to make any changes, what we'll do is we'll just make a revision for any one of these tasks. Go ahead and create the task, and we'll view the task definition. We'll head back into clusters, weather demo. If we take a look at our other tab and refresh, we can see that our temperature service is running. If we take a look at logs and refresh this, things are looking good here. Standard .NET logs, we're running on port 5000. That looks good. So I'm going to go ahead and close this window. And now we're going to create our last service, which is our report service. So we'll go to Fargate here. Task definition here is going to be weather report. Latest revision. We'll call this report service, or weather-report maybe. Report service, I think, is what we want. Number of tasks is 1, and everything else is the same for now. Select the appropriate VPC. I'm going to place the weather report itself in any one of 2 public subnets. So we'll go ahead and select our public subnets here. Security group, same security group. This just needs access to port 5000 for now. And then if we scroll down here, no load balancer, next step, no auto scaling, next step, create the service. Okay, so we'll view our service. Now what's different about this service is that we are going to get a public IP address. So let's go ahead and refresh. We'll wait for this to be running. We click on the task, and we can see that it has a public IP address now because we auto-assigned a public IP address for it here, and we placed it in a public subnet. Okay, we could use this to query, but we don't have any data in our RDS instance. So the last thing we need to do is to create a task definition for our data loader. So let's create a task definition here, Fargate task. We'll call this weather data loader. Same role, also Linux. Minimal memory and CPU. Add a container here, and we'll call this weather data loader. Here we need to actually go back to ECR and find the name of the weather data loader URI. So we'll grab this, paste it in here, latest as the tag. We don't need to worry about port mappings in this case. But let's take a look at our config in the data loader. So if we head back into our data loader and our app settings.json, we need to create environment variables that map to services _temperature _host and precipitation _host and port. So let's set that up now. We can scroll down, or rather up, to environment variables. So services temperature host, services temperature port, services precipitation host, services precipitation port, and don't forget these are double underscores. Our ports are 5000, and if you don't recall the hosts on which each of these are running, we can just head back into ECS. We can take a look at our clusters. We can take a look at precip service and temp service. I'll open these up in separate tabs. We view the task for each of these, and we grab the private IP address here for our precipitation service. So that's our precipitation host here. And then we grab the private IP address for temperature under tasks, click the task name, and then click, or rather look in the network section here for the private IP address for temperature. Okay, we scroll down here. All else looks well. So we go ahead and add this, and we create it. Now our data loader is not going to run as a service. It's not a long running task. It's sort of a batch process job that runs once, and then the container should die. So it should just spin down. We'll take a look now at our cluster, and we can actually fire off this task by visiting the tasks tab and run a new task. We'll select Fargate, Linux, task definition being our data loader, And then we'll, of course, select the weather demo cluster that we have. We can set up a task group here. We don't need to worry about any of this. We'll run it in our VPC, and we'll run this. Doesn't really matter where. For now, we could run this in a private subnet. That's fine. We don't need to auto-assign a public IP address. And from a security group standpoint, there's nothing that should be connecting to this service. It's just actually making HTTP requests out to our precipitation service and our temperature service, so that's fine. We'll just go ahead and run it and see what we get here. So we'll click on the weather data loader task ID, and we can see it's in a pending state. If we refresh, it should very shortly be in a running state, if all is well. Okay, so we're in a stop state now, so let's take a look at the logs. So in fact, what we see is that the system did not find this app-settings.json file, and it's not optional. So what we have here is an issue where we probably didn't copy the app-settings.json file in, sort of like we had set up for other services when we saw this earlier. So we can fix this, and this is actually a good exercise to look at how we could actually deploy a new instance of our data loader in this case when we have an issue like this. So we'll head back into the code, and if we take a look at the data loader app settings, we can select properties here. And in fact, what I see here is this file name app settings with a capital S, and we have looking for app settings here with a lowercase s. In this case, if we take a look at what we're actually trying to load in the program.cs, we're specifically looking for app settings lowercase s. This is interesting, and it's because when we tested this earlier, we were running this on Windows. My development machine for this series is a Windows machine. If we had, which is case insensitive in this particular case, if we had made this app settings.json capital S, then things would have probably worked for us. All right, so let's go ahead and change the add.json file to capital S here. What we're going to do is rebuild the solution, and then we're going to head back to our terminal. So we changed this to capital S, and then what we're going to do is head back to the terminal here. We're going to close Notepad that was open earlier. We're going to go up to cloudweather.dataloader. We'll go ahead and build the solution. And if you get this interesting error here, 54 errors, where the compiler is complaining about the Docker file, if we take a look at the Docker file here and select properties, the build action, it's not a C# file, so we just want to say none here. We can say save, and then we should try to build again here. That's an interesting error. And then we can save all, and then we'll go ahead and run a .NET clean, and then a .NET build. So if your IDE is trying to compile your Docker files as C# files, then you may run into that kind of interesting error there. But in any case, what we should do now is we should build and push our ECR image for our data loader project. Hopefully this resolves our app settings issue. Okay, so we've tagged and pushed our data loader ECR image. And in fact, if we head back into ECR, let's go ahead and open ECR up in a new tab. And we take a look at the data loader repository, we now see a second image here where we've untagged effectively the previous revision, and latest now points to the image that we just pushed with that minor change. Okay, so we head back into ECS here, and really all that we should need to do is ECS is going to pull the latest Docker image, the one that's tagged latest here, and run it. So let's go ahead and try to run this again. We go back into our weather demo cluster. We're going to run a new task, Fargate, Linux, weather data loader, one task group, correct VPC. We're going to put it in a private subnet. Just put it in one. I think that's, of course, fine. We don't need to worry about a security group here. And we'll disable auto-assigning a public IP. Go ahead and run the task. And this time, we'll see if it works for us. We'll click on the task ID, and we'll wait just a minute to see it hopefully get to running state in this case. Okay, so we're running. Let's take a look at the logs, and we'll refresh. Okay, so now we're getting a new error that we should try to resolve here, which is that the URI format exception, invalid URI, the host name could not be parsed. This is in program.cs line 33. So let's try to debug this one. We'll head back and we'll take a look at data loader program. We head down to 33. So this is actually interestingly trying to create a precip HTTP client. So we see precip service host and precip service port. So let's head back into where we're getting these from. So this should be precip service config host and port. Precip service config is the section precipitation. And if we take a look at our app settings.json file, we do have a section precipitation and host. So our environment variable should be services __ precipitation __ host. So we're getting that we have an invalid host, invalid URI, the host name could not be parsed. So I think what we should do now is go take a look at the task definition for data loader, and we can see that here. We'll scroll down, we'll click on the container definition, and I see services precipitation host, precipitation port. That looks fine. Port 5000, that looks correct. So one thing we could do here is if we wanted a little bit of additional information, our logs here are actually not great. So we head back to where we were looking at the logs. What we can do here is we can say console.writeLine. And we'll say our precip config. And what I'm going to do is just copy this value. And we'll paste that here. We'll just make this some string interpolation for us. And we'll also say our temperature config, or temperature config is this, temp service host, and temp service port. Okay, this provides just a little bit of additional logging, so we'll run our script to push our changes again. Now that that's been pushed, let's go ahead and kick off our task again. We expect it to fail, but we will see it hopefully log some additional information for us. So we'll head over to our task definitions, and we'll run our weather data loader as a Fargate task on Linux. Task group 1, cluster VPC, same cluster, and we'll put it in a private subnet without a public IP address, of course, and we'll go ahead and run this task. So this time, hopefully, we see what the host name and the entire URL that's getting passed to our HTTP client actually is. So we'll click on the task. It will be running here shortly, and we'll view some logs. Okay, interesting. So we do see starting data log here, but we are getting an unhandled exception that the hostname could not be parsed, program.cs line 36. And it looks like there is a space in the precip config. So that's our error. What we need to do is now head back into our task definition for this and update the container to make sure that we don't have a space here in our environment variable or in the code. Let's check the code first just to be sure. We'll head back into the code, and this was specifically the precip config. So precip config here does not have a space in it, and so I suspect that this is a space that's in the actual task definition. So we'll head back into task definitions here. We're going to take our data loader and we're going to create a new revision. And we're going to scroll down to our data loader here, scroll down to our environment variables, and indeed I do see a space here, unfortunately. So make sure that you don't have spaces in any of your environment variables, or else you'll run into an issue like this. We'll go ahead and update, create the revision. So now we have a new revision of the weather data loader task. we can actually just run it directly from this screen now. So Fargate, Linux, everything else is the same at this point, should be pretty familiar at this point. We'll run this in a private subnet without a public IP address, and we'll run the task. So if there are any other issues, we'll take a look, but hopefully this will be a working data loader. Let's click on the task. We'll go into our logs here, and we'll just keep an eye on the logs. Okay, so now we can see we're actually processing a zip code, and we're starting the data load. If we refresh, not seeing any errors at the time being, so that's a potentially very good sign. We should now be able to check as to whether or not data is actually getting written to our database. In our case, we can look either at the logs from our temperature and precipitation microservices, or we could also take a look at the Postgres database. So let's look in Postgres here, and what we'll do is we'll select from temperature. So we'll go ahead and run a query tool here and select star from precipitation. Okay, unfortunately we don't have any results here. Let's go ahead and query temperature. This may be another error that we will need to fix here. Select star from temperature. And we don't have any temperature results either. Okay, so let's head back to the logs and see if we have any errors. And in fact we do. So we're getting a 500 response back, internal server error, when we are attempting to make a post request. And so we can debug this by looking at the logs from either our precipitation or our temperature service. So let's go back to our temperature service. So we can go back to our cluster, weather demo, and our temperature service. We'll look at the logs here over the last 30 seconds. So we can see an error here. And we're timing out, attempting to connect to Postgres on an internal IP address here, which is very interesting. So a couple things to check here. If our internal microservice here, our temperature service, is timing out when attempting to connect to Postgres, there are a few things that could be happening here. For one thing, we know that it's probably not an authentication error. We would actually see that here. But what it means is that for some reason, the connection string that we're using to make the post request is timing out. And so we should go, for one thing, look at the security groups that are attached to the database to make sure that they're accessible from this service in particular. Let's go to RDS for this, and we'll take a look at the security group here. PG access anywhere. And if we take a look at inbound rules, we do see access from a particular range of IP addresses within the VPC. What I want to do here is just edit inbound rules here and actually change this to be from anywhere for the time being. We're going to go ahead and save this, and now we're going to head back to ECS, and we're going to once again try to run our data loader and see if that resolves the issue. Alright, so we'll head into our task definitions. We'll head over to weather report. We're going to head into weather data loader. We're going to run this task once again. Linux, one task, weather demo, correct VPC, private subnet, disable public IP, and run the task. Okay, so let's take a look at this again. On the old data loader, we can actually just go ahead and stop this task. And now we'll keep an eye on the new weather data loader task with our security group updated. So it's running. We'll head into logs here, and we'll try to keep an eye on what's happening in the logs. And yet again, we're plagued with another error. So let's head back into the logs for our precipitation service and see if we can see anything new happening there. So we're on a bit of a bug hunt for the time being, and that's okay. That's sort of part of the process here. Okay, I see another error occurring when saving changes. Permission denied for table. Interesting. All right, so we're seeing now some permission errors. We have another error here as well, and failed executing the database command. All right, so I can see a lot of writes are attempting to be made, meaning our service is actually running. However, we are basically being denied permission to write on this particular table. So that's interesting. If we head back, we should stop this task, but I think we can actually solve this particular issue relatively simply. So let's go into weather demo here. I'm going to go into tasks, and we're going to, okay, nothing is running anymore. That's good. We want to make sure that the user that we created earlier, our weather stage user, has access to actually write to the databases that we've created here. And so what I'm going to do is I'm actually going to disconnect from our database server here to debug this. And now I'm going to try to change the properties here of the connection. We're going to change the username here to weather_stage. And we're going to try to save here. And then we're going to try to connect. And we're going to change or use the password change me ! Okay, so we can connect. If we go into cloud weather temperature here, and we get a query tool, and first let's try to select star from temperature. And so we can see that we actually have permission denied for querying this table, and certainly we must have permission denied for inserting into this table as well. So let's try to explicitly grant read and write access to all of the tables that we have here. We can do that as our Postgres user. So again, I'm going to disconnect from the server here. We'll disconnect. We're going to select properties, going to connect back as the Postgres user. And then we'll try to connect again. Okay, so we're connected. Now let's see what actual permissions are on each of these tables. So for this, I can use a command, select grantee privilege type from information schema, role table grants, where the table name is equal to temperature, but we want to run this on the temperature database. So I'm going to go ahead and right click on temperature and run the query tool here. Okay, so only Postgres has these privileges. We need to make sure that our user has privileges as well. And I'm going to write a better grant all privileges. So we're going to grant select, insert, update, delete on all tables in schema public to weather stage, which I believe is the name of our user. We can double check that. Once again, weather stage. Okay, so this will be for temperature. So let's go ahead and we'll just run this command for now. And we granted that. Now if we actually run this query, we can see that weather stage now has the ability to work with this database. We're going to run this same command on the precipitation database, so we can go ahead and do that. And we'll run it on the weather report database as well. Okay, so a little bit of SQL administration here for the user that we're setting up. But again, this may be the type of thing that you run into in the real world, so I do want to include this as part of the video. It's something that I ran into making the demo, obviously, and I'm just walking through the way that I might sort of debug this and fix the problem. Okay, with that being the next thing that we fixed, let's go ahead and once again try to run a task for our weather data loader. So weather data loader, the VPC, the private subnet, no public IP, necessary, and we'll go ahead and run the task. And then, as always, we will watch the logs and make sure that things are, this time, hopefully running smoothly. And if not, we will debug once again. So let's wait for this to be running, and then we'll take a look at the logs. Okay, so we're running. Let's take a look at our logs, and fingers crossed, we are doing just fine. And it looks like things are good. So we're now posting some temperature and some precipitation data to our database. We should be able to actually go ahead and just close a bunch of panels here. So I'm going to close these out. And let's just query our precipitation database now. So we can open the query tool here, and let's just select like star from precipitation, limit 10. And finally, things are looking good. The data looks good, and we can do the same for temperature just to check. So we'll select star from temperature, run this against temperature. So we'll write our query tool here. And temperature is also getting its data, so that's good news. Now we're just going to wait for the data loader to finish its process. So we're going to get a separate log out here, one for each of the zip codes. Once that's done, and we can see it's still running, once the task is stopped, and it is now stopped, we should now be able to query our weather report that's hosted in Amazon ECS, running as a microservice. So let's head back into our cluster. We're going to grab the report service. We'll look at the task again, and we'll take a look at this public IP address. And here we'll just use our browser to query port 5000 / weather report. And then zip code here could be one of our zip codes. And then days could be like 5 or 4. Okay, and so now we have another little bug to fix here. We're getting a 500 error when we are trying to make a request to this endpoint. So we can debug that again by looking at our logs. We'll head back into ECS here, and I'm going to go to our clusters. We'll close some of these other windows. Let's take a look in weather demo. Now we're looking at report service, and we want to look at report service logs. So we see our error here. Let's take a look. So we had a connection refused error. Let's see what else we see here. Okay, so an exception occurred in the database while saving changes. Exception has been okay, so failed to connect. Aha. So we see we're trying to connect to 127.0.0.1, port 5432, which is localhost. So for some reason, our weather report is not attempting to connect to our RDS instance. So let's fix that. We can head back into the task definition for weather report and try to debug what's happening here by looking at the container definition. And I see that we do not actually have an environment variable for the database, which is going to cause this problem. So we need to make a revision. So let's go ahead and create a new revision here. And we'll go down to our container definition. We'll scroll down here to our environment variables, and we need to add a new environment variable. So if we remember back to our weather report service, in app settings.json, we still have this connection strings __ appdb. So let's go ahead and add that. And now let's grab our original connection string here, copy this, we'll paste it in, we'll get rid of the double quotes. We need to change the host to our RDS instance. So we'll head back into RDS in a new tab. We'll grab our weather stage database. We'll grab our endpoint here. So this needs to be in place of localhost. Port 5432 is fine, except that our username should be weather stage. And our password should be change me ! And our database should just be cloud_weather_report. You can also double check this from pgAdmin as well. So we can see that here, cloud_weather_report. And so everything else should be the same here. We end in a semicolon. And so I believe this will set us up with the appropriate connection string. So we'll update this, go ahead and create the revision. And then now that a new revision has been created, let's head back to our cluster. We'll click into Weather Demo. We're going to take a look at our report service and look at tasks. Now we're going to select report service and we're going to update report service. So now we see a way to actually update a long-running service with weather report here. We want to grab revision 2 now. And then this is all good. We don't necessarily need to force a deployment in this case. If we're sure that things are going to work for us, we're going to go ahead and go to the next step here, the next step, and update the service. So if we take a look back at the service now, we can see that we have a status primary and a status active on 2 different deployment IDs. One which has been completed, in other words, it's been completely rolled out, and another rollout which is currently in progress. So we can see this under the Deployments tab. If we take a look at tasks, we now see that Weather Report 1 is still in a running state, while Weather Report 2 is in a pending state. And so shortly, we should see Weather Report 2 be in a running state, and then Weather Report 1 be stopped. And so in this way, we're rolling out a new revision of our updated task, which contains that added environment variable, which hopefully solves our bug where we were unable to connect to a Postgres database because it was using localhost as the default there. Okay, so if we refresh this, this should actually happen relatively quickly. Now we see both are running. And now we see just whether report 2 is running. And so let's keep an eye on the logs here as well. So far things are looking good. Let's go ahead and try to make another query to our endpoint. And one thing that we want to do here is actually we want to go to the task that's running now. And there's a very good chance that this is running on a different public IP. So we're going to replace that here. Again, we don't have any DNS set up, but we're going to run the same query. And hopefully we get a result this time. Okay, and in fact we do. Okay, so we can now see that we've hosted our 3 microservices in AWS using Amazon ECS. We've looked at how to network these containers together and to have them collaborate to produce some useful information for our user. So I hope you've enjoyed walking through this. Hopefully you've gotten to this point where you can actually deploy and explore the use of ECS yourself by writing these .NET microservices, containerizing them, and then deploying them to the cloud. I'm now going to walk through the process of tearing down any of the resources that we provisioned together. This will just take a minute, but it will ensure that you're not using any resources that you provisioned and not potentially paying for anything that you're not using. So what we're going to do is head back over to ECS here. The first thing that I'm going to do is just go ahead and tear down our cluster. So if we go to clusters, we select weather demo and we select delete. We're going to try to delete it, and what we're going to find is that it's most likely going to ask us to actually delete. We can't delete it when tasks are active. So the next thing we'll do is we'll come into tasks and we'll stop all. And so now that all of our tasks are complete, if we try to delete it now, it may give us a warning that we actually need to delete some of the resources in our VPC potentially. In this case, it didn't, but I would like to actually delete the resources in our VPC as well. So we've now deleted our ECS cluster, and that's good. We're going to head back into the VPC, and we're going to find the custom VPC that we made just for this particular demo, weather demo VPC. If we try to delete the VPC directly, you'll see that it's asking us to first delete the NAT gateway and these network interfaces that are in use. So we should be able to take care of that just by deleting the NAT gateway. So we'll open this up, and we're going to just simply delete it. Be sure that if you have other NAT gateways that you're deleting the NAT, that is the one that you created for this project, of course. So that's deleted. Let's go ahead and try to refresh here, and then we'll try to delete now. Our NAT gateway is still in a deleting state, so let's just wait for that to finish. Okay, so now let's delete this remaining network interface, and we'll go ahead and try to delete it here. Okay, if it says it can't be deleted because the network interface is currently in use, we should actually make sure that our RDS instance is deleted. This is our RDS network interface. So for this, let's head into RDS. We need to tear down this database anyway. And so let's wait for this to load. We'll take a look at our DB instance here, weather stage, actions, not reboot, sorry. Actions delete, and we can type delete me and delete it. I'm not going to worry about creating a final snapshot. We're retaining backups. And we're going to acknowledge that. Of course, it is a crucial idea to retain your automated backups and create a final snapshot if this database were in any type of actual practical use, but we're going to delete it. It was just in use for the demo here. Okay, so that will be deleting for just a minute or so. Once that's available, or once that's completed, we will actually be able to delete the RDS network interface if it isn't already deleted by the delete process kicked off in RDS. Okay, so now that that's deleted, we'll finally head back into the VPC, and we should be able to delete our VPC now. Okay, so we'll delete. This is going to delete the security groups and the internet gateway that was created earlier. Be sure that you're deleting the VPC that you created for this demo and not any other VPC that you're using in your account, of course. Okay, and with that, we should have all the resources that we provisioned now taken down. And so I hope you enjoyed this series. Hopefully this was a great introduction to sort of the basic mechanics of microservices and .NET running on AWS. If you have any questions at all, please leave them in the comments below. And I would really appreciate it if you liked and subscribed to the channel for more videos about .NET on AWS, as well as a variety of other software engineering topics. Thanks for watching, and I'll see you next time.